Imagine a world where death is no longer the end, a world where your thoughts, memories, and personality can live on. This is the promise of mind uploading, a concept once relegated to science fiction but now edging closer to reality. Mind uploading proposes transferring your consciousness to a digital substrate, potentially granting digital immortality. Imagine preserving the minds of our greatest thinkers, artists, and leaders indefinitely. Picture exploring the universe as digital beings, free from the constraints of space and time. Mind uploading presents exciting possibilities and profound ethical dilemmas. It forces us to confront fundamental questions about consciousness and identity. As we stand on the precipice of this revolution, we must engage in thoughtful dialogue. The journey is fraught with technical hurdles and ethical complexities, but the potential rewards are too great to ignore. The future of our species may depend on it. At its core, whole brain emulation is based on the premise that the human brain, for all its complexity, is ultimately an information processing system. This system, composed of trillions of interconnected neurons, generates our thoughts, emotions, memories, and everything that makes us uniquely us. Whole brain emulation, therefore, seeks to create a digital replica of this intricate neural network.
Imagine meticulously mapping every neuron and synapse in your brain, creating a detailed blueprint of your unique neural architecture. This digital blueprint would then be used to build a computational model. This model, running on a sufficiently powerful computer system, would essentially function as a digital twin of your brain.
Theoretically, if this model were accurate and comprehensive enough, it would capture the essence of your consciousness. Your thoughts, memories, and personality would be preserved in digital form, potentially allowing you to continue existing and experiencing the world within a virtual environment. This concept, while still theoretical, is rooted in the rapidly advancing fields of neuroscience, computer science, and artificial intelligence. While we are still far from achieving true whole brain emulation, the progress made in these areas in recent years suggests that it may not be as far-fetched as it once seemed.
The quest to emulate the human brain is not just a scientific endeavor. It is a journey into the very essence of what it means to be human.
The journey of uploading a mind to a digital substrate is a multi-stage process, each step building upon the previous one. The initial step involves creating a comprehensive map of the brain. This requires imaging the brain at an unprecedented level of detail, capturing both structure and dynamic activity.
Once we have a detailed map, the next hurdle is to interpret it. This involves deciphering the brain's language, understanding how neuron patterns translate to thoughts and emotions. Advanced algorithms and AI sift through vast data to decode the brain's complex signaling.
The next stage involves simulating the brain's activity on a computational platform. This requires immense computational power, potentially new computing paradigms like quantum computing. The final step is transferring consciousness, raising profound philosophical questions. Can consciousness be copied like data, or is it inherently tied to our biological substrate? The path to mind uploading is long and arduous, but the potential payoff makes it a journey worth pursuing. Mind uploading is not merely a biological challenge, but also a technological one, demanding breakthroughs in multiple fields. At the forefront is the need for advanced neuroimaging techniques capable of mapping the brain's intricate structure and function with unprecedented resolution. This goes beyond simply visualizing the brain's anatomy. It requires capturing the dynamic firing patterns of billions of interconnected neurons.
Once we can map the brain, we need to make sense of the data. This is where artificial intelligence and machine learning come into play. Sophisticated algorithms are required to analyze the vast datasets generated by brain scans, identifying patterns and correlations that reveal the underlying principles of how the brain processes information.
Simulating the brain's activity requires immense computational power, pushing the boundaries of current computing technology. Quantum computing, with its potential to perform computations exponentially faster than traditional computers, could be a game changer. Quantum computers could potentially handle the complexity of simulating a human brain in real time.
Data storage and management present another significant hurdle. A single human brain generates an astounding amount of data. Storing, accessing, and processing this data efficiently will require breakthroughs in data storage technologies, potentially involving DNA-based storage or other novel approaches.
Finally, the ethical implications of mind uploading cannot be overstated. As we develop these powerful technologies, it is crucial to establish ethical guidelines for their use, ensuring they are used responsibly and do not exacerbate existing social inequalities. The future of mind uploading depends not just on technological progress, but also on our ability to navigate the ethical complexities it presents.